Now we're streaming. Okay, do we have all four? If you have all four, please have a seat. Evan, you need to make a decision. Just make a decision. Make a decision on those last two.
I just came to stop.
Oh, okay. Why do you have a two of them? If your thing is properly balanced, you should have no numbers. They're all going to be 1 to 1 to 1 ratio. Just to be clear.
Wait, so we have
Excellent. You put the H in the right spot. You put it on the end. That's weird. HSO4H. It's H2SO4.
You just did a little something I like to call copy in the back.
And did you change all the charges?
Yeah, always.
No, they're -1 each, and then they're -1 each. They have to be changed. Yeah, because H plus moves. So if there's a positive charge moving around there.
Wait, you get these all straight?
That should be HSO2. I thought it was 3. No, it's 3. But I wrote it really nice. However, you would like
What the hell are you doing?
H2.
I was playing with a little eraser thing.
And the charges should change.
Apparently the eraser thing has like,
Oh, what? I put a 16 marks.
no.
Yeah, but 16 marks isn't that like full marks?
Okay.
No, it's not.
Also, just to be clear, marks aren't due next week. Technically, your reports and your intern marks are due next week, and I can change them up until the end of next week. So I can write your report before I mark your test.
When's the last time you changed this?
But I do have to get them in soon.
I'll mark the tests myself. Can we go?
To be honest, I'm close to taking you up on that offer. Okay, this is getting out of hand. Get back in hand. Whoa! Language. Elena? I'll chalk it up to concussion. Now, in each case, they have a reasonable product, except for one. This is the only one with an H, so that has to be the acid, goes to the base, you get NO2 minus and HCl. Notice the charge is switching in this particular case. This is HCO3COO, so it's one of our weird acetic acids. That's the only one with the H. This one doesn't have one. Donates, charges change. -2, moves over. Same here. 1H moves over. HS minus. CO3 -2. Total charge on this side -3. Total charge on that one is also -3. And then we get down to here. The only correct answer is HSO4 plus HSO3 goes to H2SO3 and SO4 -2. Some of you will have SO4, H2SO4, which, to be honest, at this stage was a completely reasonable assumption, except that H2SO4 is a strong acid. This is where I get to introduce this concept. These acids are strong, and they are strong in such a way that they always give off their hydrogen and they never take it back. So before, I said H plus of an acid, and then, no, you have to watch, this is like a critical number, okay? Isabel. Now, am I a base? Why not? Could I take an acid? Yeah. If I'm a strong acid, I'm only technically a base. I could take it back, but I won't try and give it to you. No, I'm not going to. Yes. And then you're stuck with it.
So is that like no longer equilibrium?
Yeah, no longer. So these ones, your concussion's gone. That's the most brilliant point that was made today in all of my classes. These, no equilibrium. Which means What kind of arrows do you have here? One way. What kind of arrows do you have here? Two arrows. So H2SO4, can you have an arrow that goes that way? No. H2SO4 cannot be made by this process. You have to make it by a totally different process. So that means I just happen to know that I cannot make H2SO4. It's a magic one in the same way you couldn't make HCl. So this is here to fool half of you who picked it at random, and then just so I can make that point. Now what I would like you to do is go back to your examples, and I would like you to label the acid on both sides. The base on both sides. And then join the conjugate acid base. So this acid goes with which base? Which is the conjugate acid base pair? Elena.
Can you restate the question?
This acid goes with which base?
CO.
No. That's his partner. Remember. Conjugate acid base pairs. Are we a pair? No, that would be weird and creepy. I have my acid. Sorry. Take it. No. Now I became a base. I am my own pair. Yeah, so it's there. Conjugate. Okay. And let's use a different color for these ones. Conjugate. I would like you to go back to your reactions, identify the same conjugate acid-base pairs in the three remaining, and one of the reactions suffers from the same problem as the last one. One of these reactions is actually impossible. Try to identify it while identifying all the pairs. Go back to the boards. Fix them if they're not quite right.
How would you go that way? Isabel's laughing.
Isabel's last name?
She's laughing.
She left.
So I don't know.
Maybe I scared her with my demo.
I wouldn't.
Too much talking pairs.
Yeah, I wouldn't say that's impossible.
So we just what? This one and this one and this one and this one.
Hold on.
Once you've paired them, identify the reaction that's actually impossible. It makes a product that cannot be made because it's one way.
Is it really just that?
The other way.
We get it right.
Which one's impossible? Nope, that's the one. That's what I went over. You can't make H2SO4, and you didn't. That one's fine.
Is it the third one?
But one of them is impossible as written.
Is it the third one?
Nope. What kind of acids make it impossible from your sheet?
Is it the last one?
Because remember, I looked at here to do it.
Because they're both bases.
Looked at here, the top gray section,
It's okay, here, back.
and take it away.
It's the
It's
first
the
one.
first one. Okay, guys. No, it's the last one.
It's the
Because
first
it's
one.
HCl.
Yeah.
Because of HCl.
Because of HCl.
Due to the HCl.
Okay, everybody have them paired? Yes, yes. Your charges on the first one are a little odd. Yeah, HNO2 doesn't have a charge, it's correct. Cl minus, however, and then NO2 minus, but HCl shouldn't be a positive. I think you just forgot to put the charge. You moved it correctly. You just wrote it down mistakenly. You've got that one. Identified.
Crushing it.
Identified.
I don't think they're broken. Are they? I don't know.
Nicely signed. Impossible, not one. Oh, whoever was working here, you only identified one pair each. There's two pairs for each one. Yeah, there's two pairs for each one. So that one and that one are pairs. And also that one and that one. You should. Oh, yeah, you got two. You still got it. Still got it. That one's impossible. You got your pairs. And why is it what?
Yeah, but like, they can't go down. Anatomy can, but I don't think it will. But I don't think it will, because I don't think you use that.
Good identification. Impossible.
Both grids play 2%.
Okay, all good. They look good.
Like two tests, increase rate by 2%. Are they tests or are they?
No,
Have
a seat. So you can't create HCl this way. It does make it completely impossible. It has to go the other way. It immediately dissociates into this. So this means this reaction would just never go. If you added HNO2 to Cl minus, it would just stay as HNO2. It wouldn't actually react to Cl at all.
Wait, what? I thought it would just go that way.
Because HCl is a strong acid, only goes that way. So there's no equilibrium with any of the strongs, so it can't go backwards. Okay. Nope, put it there. Okay, some definitions. Amphiprotic. AM, that's clearly an M. Amphiprotic. It's the same root that you get the word ambidextrous from. It's just the two roots have become a bit garbled over the time, so now they're different in different words. But amphiprotic means your proticity can be in either direction. You can be a donor or an acceptor. You have twice the chance of a date on a Saturday night. Because you can donate or receive. Now, to be amphiprotic, you obviously have to have an H plus. So to be amphiprotic, you have to have a hydrogen to give. But you also have to be able to attract an H plus. What would you need to attract an H plus? Water is amphiprotic, and it doesn't have this particular quality, but what would help attracting an H plus? A negative. So they're often negatively charged. So they often have the formula HX minus or H2X minus or HX minus 2, some sort of amount of charge and amount of hydrogens. So they could take another one, or they could give one up, depending on the species that they're with.
Have you drawn an H over the H?
Yeah. I drew an H over the H and an X over the X, just to highlight it. How do you know? On a practical level, if you can find it on both sides of your acid-base table, it can do both. Let's pick a version, HSO3. Could this be amphiprotic? Based on the rules I just said? Yeah. Yeah. I've got a hydrogen, got a negative charge. It's right here. Can we find it on the other side? Is HSO3 on the other side?
Yes. Yeah, it's at the
Where?
sulfurous.
There we go. So here we have an example of it being both an acid, and when it's an acid, it gives off an H to become SO3 minus 2. When it's acting as a base, it will retrieve one. Here it's becoming an acid to become HSO3 minus. That going the other way will become H2SO3. So here it's acting as a base going that way. Here it's acting as an acid going this way. Your table is written as acid reactions. So they're all made as if you're giving up an acid. But if you just reverse it, they're all basic reactions. There's also some strengths. The strength of the acid is highest up top, and the strength of the base is the highest on the bottom in terms of how that goes. Given what you know out of ions, what is another potential amphiprotic molecule? What other HX minus formulas do you know? Some amount of negative charge, some amount of H's. H2PO4. You need a charge for that?
Negative.
Yeah. You've lost one hydrogen. Can we find H2PO4 on both sides?
Yeah, at the bottom. H plus plus PO4.
H plus.
Is that the same thing?
No,
H-
go up. It's like a little trick.
Where's H2PO4?
Stop right there.
Oh, there we go. Yeah. I'll circle in a different color. Now, can we find it on the other side?
Is it not?
There it is. So yeah, that works. H2PO4 is amphiprotic. Anybody got any other ones? HC2O4. HC2O4 minus, I'm assuming?
Yeah.
Can we find it in both sides?
Yeah.
There's that one, and what other one is there?
There's oxalate.
Oh, here it is. Yeah. So we can find that in two spots. They all have H something, so H2, H1, H3.
Wait, so is it an acid and a base?
So it's an acid and a base. It has twice the chance of a date on a Saturday night.
Wait, what about the one that's like dihydrogen citrate ion? Like, is that still the same thing?
Which one?
H2C6H5.
H2C6H5. If
Oh, up. Right
this
there.
one?
Yeah. Is that the same thing or does that not count?
As the same thing as what?
As
Because there's this one. That's on both sides. Can you find another version of this one? Oops, do that in a different color. Can you find that on both sides?
Yes.
Where's the other one?
Citric.
Oh, yeah, there it is. So that is the, now, citric acid is this. This is the product, but citric acid has 3 hydrogens. It's triprotic. So it can give off a hydrogen, and then it can react again, and give off a hydrogen, and then that can react again, and give off a hydrogen. What about HSO4?
Wait, so you said
Mine.
citric is tri what?
Citric acid is, I'll define the terms down below. It's triprotic. What about HSO4? Is it amphiprotic? Why not? Well, it itself is not a strong acid, but you were on the right track. Yeah, it's in here in the gray area. Can it go that way? No. So it is the conjugate base of a strong acid, which means it's an infinitely weak base. It can never act, it can never go the other way. So this is only an acid.
So if it's in like the gray, then
Yeah.
it doesn't work.
Yeah, if it's in the gray, it can't. And the only one that would fool you is that one. That's the only one that that could go, that looks amphiprotic, and you think, oh, it should be able to do both. No, it can only be an acid.
What about
It is also true that none of these can act as bases. So Cl minus cannot take a hydrogen and become HCl. So the conjugate bases of strong acids are not bases. We call them conjugate bases just because they're their partner, but that's it.
Was that the gray one at the bottom, the very small ones? Is that the same?
Up here,
No, at the very bottom.
same thing. Just as we have the strong acids here,
Yeah.
we have the strong bases here.
Okay.
This list is not nearly as useful because the strong bases given here are O minus 2 and NH2, and those do not correspond to the strong bases you know and love. Give me a strong base from like grade 10. Yeah, what kind of OH? NaOH. We've just done solubility. Is sodium soluble with hydroxide? Yeah. Is it 100% soluble? Or is it forming equilibrium?
Oh no.
If you look at the table, it's pretty much soluble up to 0.1 molar. It is soluble. So it gives off OH minus and Na plus. Those are spectator ions. And so all of the strong bases are also all of the alkali metals with hydroxide. So all the hydroxide, the ionic compounds, are strong bases by definition. And they're not on the table because it's a solubility equation that gives them. The only ones that are on the table are the ones that aren't a solubility equation. And as the oxide ion will rip a hydrogen off of anything around it to make hydroxide. So all of these compounds are also bases. And if you ever manage to make NH2 minus, God forbid, it will immediately become NH3. NH3 cannot act as an acid. So these are never acids. Makes sense? Hydroxide for a long time was thought to be what base was in the Arrhenius definition, so it makes sense it can never be an acid. And NH3 can never be an acid. It cannot give off one of those H's to become NH2. It is the conjugate of a strong base, NH2 minus. Okay? But you can find NH3 elsewhere. Is NH3 elsewhere in here?
Yeah.
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 We have it there. It can act as a weak base. So it can't act as an acid, but it does act as a weak base. Okay, put in, view, zoom, my page width. Down here, we were going to come up with a lot of examples, and we already did that on the other page, so I'll just bring it in. We had, I believe someone said H2PO4 minus. We have HCO3 minus, HC2O4 minus, HCOSO3 minus is another example. And then never HSO4 minus. Conjugate of strong acid. Cannot be a base. Monoprotic and diprotic and triprotic are just defined by example. I will ask some people for an example. Give me a monoprotic acid, please. Portia. A monoprotic acid. Monoprotic. One. I need the end. Any end. The one in your stomach.
HSO.
Oh yeah, that works. HSO,
or HSO4.
yeah, and put a minus sign. That is a monoprotic acid. It only has one hydrogen to give off. It's a more complicated example. And so it only has one hydrogen to give for its country. B, a diprotic acid. H2SO4. A little trickier now. You got to see if on your table you can find a triprotic acid. I'm going to say you're not allowed to give me citric acid. Evan. Do you have your table in front of you?
No.
Ah, well that would be what?
Okay.
Oh no, I'm asking you. You already gave me citric acid, which is why I picked this one. No. Evans. Give it.
Is the charger?
Remember, if a student is required to answer, and I'm giving them time, when you offer the answer, what you're saying is, Mr. Neufeld, we believe you to be so mean that in a second, if the student doesn't come up with the answer, you're going to kill them. And we're trying to save their life. And that hurts my feelings.
Phosphoric acid.
Right, what's the formula?
H3PO4.
H3PO4. See, they get there eventually. And I always remember back when I was learning to be a teacher, the example the teacher gave. He gave it live in a class. He was asking questions. It was he worked at Sully's, and he was asking questions of the class. People were responding, and then at one point, the student, as he inevitably did, said, "I don't know." And then he went, "Oh, okay," and he moved on to the next student. What did every student immediately start saying? I don't know, and then you just move on. If you always know you have to give some kind of response, it just helps make sure that you're paying attention. And I also am completely aware that when I ask you a question, that can induce fight or flight. You probably know it, possibly, and it's just gone from your memory because I've asked you a question in a stressful circumstance. But also your ability to recall under a stressful circumstance actually improves your ability to remember it later under the same circumstances, like, say, a quiz or a test. So it is on purpose. It's not just a torture. The torture is just an unexpected positive side effect. So a conjugate acid is a substance that has the proton. A conjugate base is a substance that lacks the proton. We have some conjugate acid, Bronsted-Lowry acid-base pairs to identify. J11 we did in a previous, in here. In a Bronsted-Lowry reaction, you have two pairs. That's all that says, which we did when we showed it to you, so we don't have to do that as a separate learning outcome. Right balanced equations representing the reaction of acids or bases with water. So what this means is, if you put an acid or base in water, it immediately reacts. It doesn't wait until you add a base if it's an acid or a base. It reacts with water. Water is amphiprotic. It is very weak on its own. And so on its own, it's really not an acid or a base, hardly at all. But if you put in something with it, it will donate a proton or accept a proton to become a hydroxide or H3O plus as normal. We've been writing these equations already. So if you're a base, you have this as a standard format. The base plus water will give the base plus the extra positive charge because it accepted it, so you just change the charge as necessary, plus hydroxide. The acid will be some sort of HX. It may also have a charge, but whatever it is, that charge will go down by 1 because it's given up H plus, and the water has become an H3O plus. Nope, I didn't write them there. What I would like you to do is write the reaction with water for the following compounds. NH3, SO4 minus 2, HPO4 minus 2, CN minus, View, zoom, entire page. Whew! And I know you're really excited to go back up to the board again. Hold it. There are people who are not here. Attendance. Attendance. B, Karen, Cole, Declan, Elena, Evan, Hannah, Henry. Preston is here. Actually, kind of close.
You changing Henry B?
Yeah, why is that not changed? There we go. And
Sienna's not
yeah, okay.
Yeah, it feels like
Excellent. Find your new partner.
That didn't work.
That didn't
Oh
change.
my god, still.
What do you mean it didn't work?
It kept Sienna in, and it kept Henry B.
Okay, I'll do it again.
Still Henry.
Maybe it hadn't saved. It hadn't saved yet. It also didn't take them out. Now we have an odd number, so that means the person who's the odd person out, Preston, you may join any group you like to make a trio, or lone wolf it and do it on your own. Entirely up to you. And it just crashed. My goodness. And it didn't save first, probably. I will refill it up if needed. 1 second. You're not on your phones in the middle of class, are you?
I can't switch my browser. I feel like no.
No, put your phones in the case. Evans rule. If you get caught, it goes over there. Actually, I should put Evan in charge.
Of what? Of phones?
Yeah, for every person he catches, you can have your phone out for like 5 minutes.
Wait. That's a steal.
Oh.
I'll forget everyone.
Desire for phone, snitches get stitches. Like, where does that balance lie?
I feel like he doesn't care about snitching. I feel like he's just gonna take the phone.
No, I'm offering people.
Yeah. Every single. That's going 5 minutes.
Oh, give me 5
5
minutes.
minutes.
Ugh.
It's fun.
Hey, I said to recover the file. Where did it go?
Can we make that a rule though?
One second. It said it was going to recover the file. When it does that, it often. Come on. Recover. It often recovers. Nope. No recovery. You jerk. Would you like to recover the lost file? Yes. Right, where's the lost file? Come on, lost file.
Okay.
I'm just going to start writing it then. Okay, the ones you have to do, I will start with the bases and rewrite them out since my recovery option didn't work. We are going to start with NH3 SO4 minus 2, HPO4 minus 2, CN minus. Acid bases, H2O2, H3PO4, HC6H5O7 minus 2, and that is a 5. View, Zoom, entire page. Excellent. Go. Matt, Evan, paying attention. Cole, what are you doing? Karis? Working? I'll come over, yes. Everyone else? Another group is already done. Get faster. NH3. Oh, it's minus. Oh, it's minus. Charges on SO4? Yeah, you're forgetting your charges.
No, we have a plus.
There was a brilliant poster made by Mia over there. I forget Cole's up too. That about making sure the charge. But it's minus 2. Excellent. HSO4 should have a charge, and CN should have a charge. And then, are you giving them positive charges? Because if you are, I'm going to hit you. And rip off your arm and give you. What?
I don't know, check it. The right is supposed to.
Yeah, what charge would HSO4 be?
What charge would H?
Hold it, HSO4.
Yeah.
It's SO4 minus 2.
No,
The next one is HPO4.
I have the ones from before.
No, but I never wrote. I wrote this thing once. Because I have one.
Wait, does
Anyway,
it have?
SO4 minus is impossible, right?
PO4.
As PO4 minus 2.
PO4. Hold on.
I may give you a quiz where the only thing I check is your charges. Ooh. Ooh. Oh, hey, 51%. I got it in chemistry degree. Nobody knows that. SO4 minus 2. So the next thing you do is go through your charges. So NH3 doesn't have a charge. That has minus 2. That is minus 2. That is minus 1. So no charge in the first one, and you're missing HPO4 right here between the SO4 minus 2. HPO4 here. View, zoom, go 50%. Oh, no. View, zoom, 75%. Is that better? Might be better. There, that's a little bigger. Is that a little easier to see? Once you have them all, have a seat, but please double check your charges. Please, Evan. Declan, what are you doing? You should be careful and attentive like Elena is. Well done.
Did I do it all of these?
Yeah, I've been rocking it.
Okay, it's SO4 is minus 2. You give it an H plus. What does it charge become?
Minus 1.
Yes. So you have it looks like a plus there.
No, it's a minus 1.
Oh, okay, then that's fine.
It's a 1 minus.
Okay, then you're good. Yeah, those are good. Hold it. Hold it. NH3 does become HNH3 plus. However, we write that NH4 plus. It's ammonium.
Why?
It just is.
But there's 5. There's 5.
No, it's not wrong. It's just weird.
Why?
Because ammonium is written just NH4 plus.
Why do you gain an extra?
It does gain an
Oh,
extra.
you're saying. Oh,
Yeah, it just that's NH4 plus.
Would you like to know what an
When we write it with H's in front, that's to show you the number that can be donated. That's supposed to be the stop stealing my stickers. No, these are given as rewards. You're stealing stickers. No, not these ones. These are recently ordered from the great 10.
Were they recently ordered from AliExpress?
No, they were not. I'm pretty sure it's a drop shipper, but I have that little distance,
I found one.
so I don't know for
Oh
sure.
my god. Wait till you see the back.
That's a lot of I appreciate that you're having a good time. We do have a lot to get through. I really want you to do this so that you can learn it. At this time, we are actually behind. Matt? Present. We're actually a little bit behind the other class. I am thinking of not having a JKL test and just having a JKLMNOP test, which we would have had anyway. But that way we don't have that first one, so we can save 2 days of the review and the extra test.
Can we take it if we'd like to?
I could possibly arrange for you to take it like in test days.
Yeah, extra.
Wait. When would we do that?
Is she unaware? Like
We're almost done. Like next week I can set the sign up.
For JKF?
No.
Oh.
Oh, sorry.
Look, I think that you will appreciate it.
When I said I'm still sick, like I'm getting super spacey, and I thought J was JKL. So we have to finish 2 more things first.
Wait, sorry, so,
But they're short. They're not that long.
so we wouldn't be doing a quiz on J? Or you're just saying we
Oh no, we might not do a full test.
but we could if we wanted to.
Yeah, that sounded like a reasonable idea.
Okay.
Yeah.
And when would that be? Like next week?
Pardon?
Next week?
Yeah.
So it would be turn 2 guys?
No. Okay. Okay. Attention. What I would like you to check now, because I actually think my fever is acting up. I'm way too spacey to read those and properly get the charges. What I want you to double check is your charges. So the number one thing you need to have for all of them is add water. Matt? I only said your name because I heard your voice and then other people were saying your name. It's weird. Now for all of these, we are now in equilibriums. B, I really do need, I am at this point seriously considering moving people like I did in the last class in grade 10. Or putting Evan in charge of phones and maybe stickers. If you're quiet, I'll give, well, it may not be much of a word.
Can we have
Give it up. Portia, I don't want stickers all over your desk. If you have them, they have to be thrown away. The gentleman who cleans my classroom is an incredibly nice man. He drew Spock on this because he saw that I like Star Trek and just drew it. He draws things for Mr. Hacker Temper on the board all the time. And he comes in, he cleans, he doesn't care how it is. And so that has made me want to make it like extra nice for him. So I don't want to give him any extra cleaning tasks like cleaning up stickers or gum or anything else. You can decorate the box, but not the desk, because he would be in charge of cleaning that up because they have standards at the school that he has to meet and doesn't have a choice over. So we can't put stickers in the wall. Okay, when we are now creating a hydroxide, we have to transfer this and ensure that we are transferring the charge. So it's not just the H, but the plus. So -2 goes down to, that's a whole class. If you add H plus, -1. -2 becomes -1. HPO4 -2 would become H2PO4 -1. So these should all decrease in charge by 1. This just becomes,
Wouldn't they all have plus OH on the end?
yes, I haven't done that yet.
Why for, if you're adding blue hydrogen to
Evan?
HPO4, why is it only -1?
What is it right here?
Yeah, because the other one's
What is it here?
-2.
So you add +1 to that.
But there's 2 hydrogen.
There was 1 hydrogen before. You only added 1 extra.
Okay, so it doesn't matter how many you have in the result, it's just only
No,
adding 1.
because PO4 is based on PO4 -3. Right? So that's a base. And then you can react it with water to make hydroxide, and it will make HPO4 -2. Then you can react that with water to make a hydroxide, and that can become H2PO4 -1. Then you can react that with the water to make hydroxide that becomes H3PO4, no charge. So it's triprotic at its ultimate level, and it just staggers by 1 each time. Does that make sense, or did you just look away because it was silly? Okay, no, I just, sometimes I lose students, and they're just too polite about it. I'll do that afterwards. What am I missing from my product here? Oh, H minus. Declan, Matt, you can't keep talking. It's distracting.
Wait, but I still feel like it's a negative charge until it's over. I'll put that.
Okay. Put that away.
It's a kindness card.
Okay, put it away. How about your notes? Your iPad never seems to have the notes on it,
It always does.
but I can see it because it's like a big white PDF, and then it's often a black screen.
What?
Now.
Save PDF.
Yeah. Now, how could you get H3PO4 reacting 3 times? Well, H3PO4 plus H2O goes to H2PO4. Now, if that gives, hold it, I'm going the other way. So if this gives up a hydrogen, what charge does it become? Minus. Minus 1 plus, and if it gives up a hydrogen, what does that become? Yeah, but what's the formula? H3O plus. And then you can just keep going. You can have H2PO4 minus 1 has a separate equilibrium plus H2O gives up a, and makes HPO4 minus 2, and then you can have HPO4 minus 2 react again to go to PO4 minus 3, and in each case it is reacting with water to give off H3O plus. I didn't want to rewrite those every single time. Karis, does that make sense? That was a very hesitant yes. Is it really a yes, or is it a yes, move on?
No, it's a yes.
Okay. The lack of confidence is what threw me. Remember, always be confident. If you can be confident, you'll be president someday, regardless of anything else. Okay. These all also react with water. And what is my non-hydroxide product? With the correct charge, please. Declan? Total charge on that side? So what the total charge on this side also needs to be nothing, so where's your missing charge? Minus there. So remember, if you're giving up a hydrogen, that charge has to go down by 1. So next one, H3PO4, which we've now done. Coal, what are the products? Now charges. Other way around. If you're giving up H plus, your charge is going to go down. You're giving up the positive, so you become negative. That feels more profound than it actually is. Last one, Isabel.
C6H5O7 minus 3
Minus 3, nice.
plus H3O.
Plus. Excellent. Is there other things I had to do on this page? I don't think so. That was the last page. So, I lost the notes there, but you got them down. I'll have to put them in some way. We have. Does this end at 55?
45.
What?
Yeah.
We don't have time for my demo? I thought it was. It is 45. Okay, so we're done J, so we can have a quiz on J next week, probably Thursday or Friday, whichever day we have class on. Just a quiz. Before you go right now, could you please go back to your board? Again, really nice man who cleaned up the classroom. Erase your board. Use only blue spray if you need a spray to erase your area out so that it's nice and clean for him as well. Oh, that means that I'm not going to the seams of the board.
Do you remember that comp test I got not getting review on?
Yeah,
I did the rewrite. Guess what I got?
you got the highest mark you could have gotten on a rewrite.
Well, I got accepted now, and then that's my mark.
Oh, good. He doesn't put a maximum on the rewrite?
I think because it was a.
Oh, okay. Because Mr. Cullis, I only know because Kirk is rewriting mine and Mr. Cullis. He did a rewrite. And he has like a maximum he'll give you for a rewrite.
Yeah.
I'm always curious what Sorry, I can't hear you. Oh, is that what you said? Let me stop recording and I can double check on the thing.